This video covers section 11.4, Properties of Logarithms. Objective 1, understand the properties of logarithms. Understanding the properties of logarithms require us to go back and talk about some properties of exponential functions. If any number raised to the 0 power is 1, then we can always write that in log form as the log equals the exponent. The base is a of 1. And so that's a property of logs right there, that the log base a of 1 is 0. Another property arises from the fact that anything to the first power is that anything. So the log is equal to the exponent of 1, base is a of a. And that property says that the log base a of a is 1. Now, e to the 0 equals 1. Says 0 is equal to the exponent on my base of e to get 1. So we would write log base e of 1, but the log base e is the natural log. So that says the natural log of 1 is 0. And that's a property of natural logs. E to the first is e, says the log base e equals 1 of e. But log base e is the natural log, so that says the natural log of e is 1. So with that being said, the log base 10 of 1 is 0 because 10 to the 0 is 1. The log base 10 of 10 is 1 because 10 to the first is 10. Log base 10 of 10 squared is equal to, well, you can think of that as the log base 10 of 100, which is 2, because 10 squared is 100. So with that same property, then, this should be 3, because 10 cubed is the same thing as 10 cubed. So these will be formalized as a property of logarithms. So as we saw, objective 1, because we know that a to the 0 is 1, we can easily see that the log base a of 1 is 0. We also know that a to the first is a, which tells us that the log base a of a is 1. We saw that on the graph of logarithms, because at 1 it was an x-intercept, and you had to go all the way up to a just to get up to 1. And so these are properties now. Log base a of 1 is 0, and the log base a of a is 1. But this also tells us that if the base is e, then the natural log of 1 is 0. And if the base is e, this matches. This would also give us 1, or the natural log of e is 1. Now, 2 more properties are called the inverse properties. So what you see there is 3 raised to this, that's the exponential portion, 3 raised to the log, base 3 of 81. So how would we evaluate this? Let's look first at the log base 3 of 81, the exponent. And log base 3 of 81 is 4 because 3 to the 4th is 81. So then we would have 3 raised to the 4th power equals 81. And so we conclude that 3 raised to the log base 3 of 81 is 81. So we like to say that these things undo each other. The exponential and the logarithmic, they undo each other. This is always true when the bases match. It's a property of inverses. So here are 3 practice problems for you to try. I encourage you to press pause in your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. If the base matches the base, then they undo each other, and we just get the number, square root of 2. And again, this is what inverses do to each other. They undo. 10 to the log of 0.2. That's 10 to the log base 10, so this just gives us the 0.2. E to the natural log. Those undo each other, and we just get 4. Inverse property 2. What if we apply the log first of an exponential expression? These should also undo each other because they're inverses. So how would we evaluate log base 5 of 5 to the 6th? So let's remind ourselves that we did 2 practice problems, C and D, like those. Log base 10 of 10 squared came out to be 2. Log base 10 of 10 cubed came out to be 3. To evaluate log base 5 of 5 to the 6th, think of this as y equals log base 5 of 5 to the 6th. Convert this to exponential form by remembering that the logarithm equals the exponent on the base of 5. So that says 5 to the y equals 5 to the 6th, and now equating exponents just says that y is equal to 6. Our conclusion is that log base 5 of 5 to the 6th undo each other, and you just get the 6 back. This is always true when the bases match. It is another property of inverses. Log base a of a to the r just gives us r. Like in our practice problems, C and D. Number 2, log base 10 of 10 squared is 2, and D log base 10 of 10 cubed is 3. Here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. Whenever the bases match, log base 8 of 8, you just get 1.2. Log of 10 to the negative 4, remember there's a hidden base of 10 there, which just leaves us with negative 4. Natural log of e is the same thing as log base e of negative 4. When these match, we just get negative 4 out of that. So again, every property that you have for exponential functions, you have some equivalent property for logarithmic functions. And this concludes the video for section 11.4, Properties of Logarithms. Objective 1, understand the properties of logarithms.